Hi, this is Group 6 and today we are presenting you with The Scribe, a 28-story tall timber skyscraper going up above 100 meters high.
So timber is actually a very viable building material, and we're going to hopefully be able to convince you why by showing you The Scribe, which is our proposed timber skyscraper. It's 28 stories tall. It's an octagonal perimeter with an exterior truss that climbs up the outside of the building. The height is 100 meters, and the purpose of the building is to provide residence for occupants, so it will be filled with apartments. The width of the building is 20 meters, and it's to be located in Brisbane.
So there are a few issues involving timber design. First and foremost, timber is typically a weaker material than steel and reinforced concrete. Large timber buildings also produce large lateral deflections at the very top of the building. In terms of material, timber is orthotropic, meaning the strength and stiffness is different in different directions. It should also be said that timber is strong along the direction of its grain.
So the design aims were to minimize that objectionable sway that's so noticeable at the top of tall buildings and achieve an overall building stability which prevents the building from falling over. Interestingly, CLT is stronger and stiffer in one direction than the other direction, and this is because when you have fibers oriented farther away from the centroid that are on the outside than on the inner layers of the cross-laminated timber, they will contribute more to the bending stiffness for that way than the other way. Because of this quirk, we orientated the columns in our building in such a way that the rectangular spans on the exterior sides of the buildings would distribute the load 50-50, even though that the spanning directions in both directions are different. In the interior, where the spans are square, we have stiffer bearers and stronger bearers where the load will distribute more to. This, however, introduces a new problem, as CLT is very prone to being squashed if it's sandwiched between two columns or two bearing pads. So we decided to opt for a solution where the CLT floor panels sit on the bearers alone, and the columns are continuous throughout the whole building from the bottom to the top. The next major feature of this design is the exterior truss, which climbs around the building. This was brought in to provide an extra stiffness and prevent the lateral swaying motion that occupants would feel at the top of the building. The idea was that having few members of high stiffness would be much better than introducing many members of low stiffness, as every connection you add increases the flexibility of the building.
So taking this concept to the next stage meant we computed some basic loads to get member sizing. Using appropriate modification factors and live loads as per design codes meant the following member sizes were approximated. So for the columns, we decided that under a compression load of 7,000 kilonewtons meant a 650 by 650 would be adequate. The bearers we took as 600 by 300. CLT we decided would be 200 mil thick. This allowed for the bending and allowances for fire. And the truss we took as a member size of 1,000 by 500. In this feasibility calculation, durability requirements such as termite protection and prefabrications were considered. Also economy in terms of optimization of member sizes and construction time was also used to assess the design. So as amazing as this structure is, it gets even better. We've considered fire in our design, so we can compartmentalize each level independent of where the fire is. We've got sprinkler systems ready to go, egress in terms of stairs and lifts, and we've considered charring depths in terms of flexural depth of the bearers and the CLT floor panels. In conclusion, we have taken this conceptual design, something which has not even been possible to attempt to construct, and turned it into something which can be replicated on Australian soil nonetheless. Thank you for taking the time to listen to this presentation. I really hope to continue this work further with you